Welcome to IS624 Predictive Analytics. I'm your professor for this course, Brian Rowe. It's going to be an exciting course. We've got 7 weeks of fairly aggressive material to cover. This first week, we're going to be covering different types of problems that you can solve using predictive analytics. Primarily, they break up into cross-sectional type of problems where you're predicting results based on other features that are within a data set, and then there are a number of time series problems where you've got a single data series that's evolving over time and you want to forecast what future values will be in that time series. For this week, one of the things that we're going to be doing is looking at different types of visual analysis and how to plot these, and this will include basic plots, scatter plots, scatter matrices, and then also a little bit of autocorrelation. We'll cover some basic forecasting methods, including like simple naive method, Holt-Winters, and then get into, in the CUNY book, we'll start talking about how to prepare data for modeling. That involves both splitting data and also fixing data for missing values or also bad values, and then moving into model evaluation. So lots to cover in this week. So talking about certain types of predictions, one sort is cross-sectional predictions based on multivariate data sets. So in Heinemann, we have car emissions that's in the data set fuel, and the objective is to predict the auto emissions of an auto-sample vehicle. One way of doing that is with a scatter plot matrix where you can see some of the relationships between the different variables. In addition to the cross-sectional, we have two types of time series data. We've got non-seasonal time series data. One example is beer production in Australia. And with this time series, we would want to see, try to predict the future beer production based on the time series that was given. And so this is what it looks like. It does actually look like there's some seasonality, but it's not as pronounced as some other data series. Seasonal time series, what we have is airline passengers, and this spans about 50 years, and what we want to do is predict future airline passenger demand from the data. And what we see, this is a more quintessential look of seasonal pattern where you have that variation that not only fluctuates per month, but also seems to grow as the overall passenger size increases as well. So some hints for the homework for this week. Because this is the beginning of the course, one of the things you'll want to do is install some important packages and the corresponding data sets. So most of the data comes from the Heinemann book, and the package used for that book is called Forecast, and then there are actually two data packages, one called FMA and one called FPP. Make sure you install both of those, and then for the homework, what you want to do is please use the following naming format. So it's first name dot last name and then underscore HW underscore week dot R. So you can see an example with my name shown below, and then that just makes it easy for everybody to know whose homework is which, and we can grade them easily. Within your homework script, what you want to do is just put in a header your name, and then each homework question, please put into its own separate function, and those must be self-contained with no callable, and callable with no arguments. So just like you see here, what you want to do is just have an empty function, and then it's easy to run, and it'll display like the either plot values or return the solution that you want. And so some of the questions have multiple subproblems, including question 2.1 of this homework. Please just separate those into 2.1a, 2.1b, and so on. And that way, calling each function, we can see the plots for each function. So this is an example of the airline passenger data, and in the upper left is the raw data, and then going around clockwise there are three different transformations of the data using the Box-Cox transformation. You can kind of see the effect of it, and when you're doing the homework, be sure to include what the objective of the homework problem is, and then also note some observations. In this case, like, how do these lambda values compare to the optimal value that if you use the boxcox.lambda function, what does that return, and why do these look different? The commentary that you provide in the comments above a function, you'll be able to reuse those when you add when you add commentary in the discussion boards. So this way you've got it in both places. When I'm reviewing the homework, there's some context to the problem, and then you can also use it when you're discussing your particular methodology for homework on the discussion boards. And that's it for this week. If you have any questions, feel free to either use the forum under Ask Your Instructor, or just email me at brian.rowe@sps.cuny.edu. And have a good week.